Hello, and welcome to Astronomy Daily, the podcast that brings you the latest news from across the cosmos. I'm your host, Avery.
And I'm Anna. It's great to be with you. Today, Avery, we'll be looking at a swarm of asteroids that could cross Earth's path, China's latest mission to the Tiangong Space Station, and a major rocket test from Blue Origin.
We'll also dive into a fascinating new theory about the Fermi paradox and why we might not be seeing advanced alien civilizations. And finally, we'll cover the European Space Agency's ambitious new plan to keep space safe for everyone.
It's a lot to cover, so let's get started.
All right, our first story is one that hits close to home. A new study is focusing on something called the Taurid Resonance Swarm. Anna, this sounds a little ominous. What exactly are we talking about here?
Well, the Taurids are an annual meteor shower, but this swarm is a specific, dense cluster of celestial bodies within that broader stream of debris. The concern and the focus of this new research is that this swarm's orbit could intersect with Earth's in the future.
So, a higher potential for impact events. What are the researchers recommending?
They're not sounding a five-alarm fire just yet. Instead, they're emphasizing the need for enhanced monitoring and for bolstering our planetary defense strategies. It's about understanding the risk more clearly.
Right, proactive observation. The study mentions a couple of specific years, 2032 and 2036. What's the significance there?
Those are identified as prime opportunities for targeted surveys. During those years, the orbital mechanics will give us a much better vantage point to observe the swarm, map out the objects within it, and get a more accurate assessment of any potential threat.
So this is a call to get our best telescopes ready for some crucial work in the next decade. A classic case of good science giving us the foresight we need to stay safe.
Exactly. And staying safe is always a good idea.
Now, moving from potential threats to definite triumphs, let's talk about human spaceflight. China has successfully launched its 10th crew to the Tiangong Space Station.
That's right, Avery. The Shenzhou 21 mission is now on its way. And by the time listeners hear this, they should have arrived. The crew consists of 3 taikonauts, and it's a mission with a few interesting milestones.
I saw that one of the crew members is the youngest person China has ever sent to space.
Yes, just 32 years old. It shows a new generation of space explorers is taking flight, and they have a very busy schedule ahead. The mission plan includes 27 new scientific experiments to be conducted on the station.
27, that's a heavy workload. Anything particularly noteworthy in that list?
One experiment that stands out is a study on rodent mammals in orbit. This kind of biological research is fundamental to understanding how microgravity affects complex living organisms over time, which is crucial for planning long-duration missions to the Moon or Mars.
Of course. And the launch itself was remarkably efficient, wasn't it?
Extremely. The launch was flawless, and the spacecraft is on a fast-track trajectory. It's expected to rendezvous and dock with the Tiangong Space Station in a record-setting 3.5 hours.
3.5 hours. That's faster than some cross-country flights. It's incredible to see that process become so refined. A huge success for the Chinese space program. Next up, we have some exciting news from the commercial space industry here in the US. Blue Origin has hit a major milestone with its massive New Glenn rocket.
Yes, this is a big step forward for them. They successfully completed a 40-second static fire test of the New Glenn's first stage. This involves firing up the 7 BE-4 engines while the rocket is securely bolted to the launch pad.
The final big dress rehearsal before an actual launch. And this first launch has a very important payload.
It does. This test is a crucial milestone for the upcoming launch of NASA's Escapade mission. New Glenn's inaugural flight is slated to carry these twin spacecraft, which are designed to orbit Mars and study its unique magnetosphere.
Sending a NASA planetary science mission on the very first flight of a new rocket. That's a huge vote of confidence.
It certainly is. And in the spirit of reusability, Blue Origin will also be attempting to recover the first stage booster after launch. They'll land it on a drone ship out in the Atlantic.
I heard they gave the booster a special name for this mission.
They did. In a wonderful nod to Star Wars, the booster is named Never Tell Me the Odds.
That's brilliant. You have to appreciate the humor. Let's hope the odds are ever in its favor.
Can't you just see the meetings where they come up with these names? A bit of space fun.
Okay, for our next story, we're shifting from the practical to the highly theoretical. We're talking about one of the biggest questions in all of science, the Fermi paradox, the famous question of where is everybody?
It's a question that has puzzled scientists for decades. Given the sheer number of stars and planets, the universe should be teeming with technological life, yet we see no evidence of it. A new study proposes an answer it calls the radical mundanity principle.
Radical mundanity. It sounds like the opposite of science fiction. What's the idea?
The principle suggests that we might be making a flawed assumption. We assume that technological civilizations will inevitably progress to super advanced levels, building Dyson spheres, colonizing galaxies, and so on.
Right. Things that would be pretty easy to spot from a distance.
Exactly. Radical mundanity proposes that this kind of super advancement might not be possible, or that it's just not a path civilizations take. Instead, they might hit technological plateaus or face existential crises that prevent them from becoming galactic superpowers.
So they could be out there, but they're just quieter, harder to detect because they aren't rearranging star systems for energy.
That's the conclusion of the study. It suggests there might be a modest number of civilizations out there with technology levels that are only modestly higher than our own. Their technosignatures would be far fainter and harder to find.
That's a really humbling thought. It changes the search from looking for gods to looking for peers. It makes the silence of the universe feel a bit less absolute.
For our final story today, let's look at how we are working to protect our corner of the galaxy. The European Space Agency, or ESA, is significantly expanding its space safety program.
This sounds like a great idea from the Europeans. Tell me more.
This is a really important initiative. Space is an environment with a lot of hazards, both natural and man-made. ESA is taking a comprehensive approach to counter threats like asteroids, powerful solar storms, and the growing problem of space debris.
Let's break that down. What are some of the key missions involved?
On the space weather front, a cornerstone mission is Vigil. It will be a dedicated observatory positioned to give us advanced warnings of potentially dangerous solar flares and coronal mass ejection.
Critical for protecting satellites and even power grids on Earth, and for planetary defense?
They are continuing with the Hera mission, which will study the aftermath of NASA's DART impact. And they're developing a new mission called Ramses, which is a rapid response interceptor concept for asteroids.
Okay, that covers the natural threats. But what about the junk we've created ourselves?
That's arguably the biggest part of the new strategy. The program is heavily focused on active debris cleanup missions. But even more importantly, ESA is pushing for what it calls a zero debris approach for all future satellites. The goal is to stop adding to the problem.
A leave no trace policy for space. That's fantastic. It's absolutely essential if we want to ensure that space remains usable and safe for generations to come.
Amen to that.
And that's all the time we have for today's episode of Astronomy Daily. From asteroids in our neighborhood to the grandest cosmic questions, there's always something new to discover.
It really demonstrates the incredible range of activity and research happening in space science every single day.
A huge thank you for tuning in. For more details on all the stories we discussed today, please visit our website at astronomydaily.io. Until next time, I'm Avery.
And I'm Anna. Keep looking up.